Hey everyone, this video is to talk about combinations, which go hand in hand with what we just talked about, factorials. So a combination is a selection of objects in which order does not matter. Order is not important in a combination, which seems a little bit weird because if you think of your school locker, you have a locker combination, but the order of the numbers do matter. So that actually doesn't make a whole lot of sense to call it a locker combination. Combinations order is not important. So our formula that we have here, n combination r, what n represents is the total, and what r represents is the amount that we choose of that total. It's going to make a little bit more sense once we have actual examples. So for this formula, we have in our numerator n factorial, and in our denominator we have n minus r factorial times r factorial. So in our first example, you order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Order is not important here because it doesn't matter which side dish you order first and which one you order second. You're still going to get the exact same 2 side dishes. So if you order French fries and mac and cheese, that's the same thing as ordering mac and cheese and French fries. So I have a total of 8 objects. Of these 8, I am going to be choosing 2 of them. My formula, that's 8 combination 2. 8 factorial over 8 minus 2 factorial times 2 factorial. This is the same as 8 factorial over 6 factorial times 2 factorial. And I'm going to go ahead and expand this. So remember, with factorials, it's the integer multiplied by every single integer below it until you get down to 1. I'm going to do the same thing with my 6. Then I also have a 2 factorial, so also times another 2 times 1. Here's what I'm going to do is I'm going to eliminate everything that I possibly can. It's easiest to look at the denominator first. You have 6 times 5 times 4 times 3 times 2 times 1. That will eliminate with 6 times 5 times 4 times 3 times 2 times 1 from the numerator. You are left with 8 times 7 over 2 times 1. Now this example isn't really necessary to simplify early because the numbers aren't that large, but it will make it easier. Looking at my denominator, obviously 1 is going to go into anything, but I can divide 2 into 8. 2 goes into 8 4 times. So basically what you have is 4 times 7 over 1 times 1, because 2 divided by 2 is 1, which is going to give us 28 over 1, or in this case, just 28. So of those 8 side dishes, there are 20 different combinations you can create if you're choosing 2 of them. The second example, you are listening to music. You have time to hear only 3 songs from your playlist of 16 songs. How many combinations of 3 songs are possible? Doesn't matter which order you hear the songs in, so this would be a combination. So I have a total of 16, and I am choosing 3. That's 16 combination 3, which is 16 factorial over 16 minus 3 factorial times 3 factorial. Or 16 minus 3 is going to give us 13 factorial. And then we still have the 3 factorial. Now, you can go ahead and you can write out 16 times 15 times 14, etc., etc., etc. Or what you'll also see for people who don't want to write all of these out because it gets a little redundant is you can just do a couple of them. You can do times dot 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 times 2 times 1. I can do the same thing in the denominator. 13 times 12 times dot 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 times 2 times 1. With the 3 factorial, I'm going to write that out because it's only 3 numbers. 3 times 2 times 1. We're going to eliminate where we can. So in the denominator, I have 13 times 12 times 11, 10, etc. And I have the same thing in the numerator. So I can cross out 13 through dot 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 1 and 13 through 1 here. You're left with 16 times 15 times 14 over 3 times 2 times 1. And here's another case in which simplifying early is going to be really helpful. So I'm going to do 2 different colors so you can see the difference here. Starting with 3. 3 divided by 3 is 1. Okay, so that one. 3 divided by 3 is 1. 15 divided by 3 is 5. Then I also have a 2. 2 divided by 2 is 1. 16 divided by 2 is 8. Yes, I could have also divided it into the 14. It doesn't matter. It's totally up to you what you want to do. So what we have from here in the numerator is 8 times 5 times 14. And in the denominator is 1 times 1 times 1. Your goal when you do this should be to get everything to cancel out except for 1's in the denominator. So when I multiply these together, that's going to give me 560 over 1. If you want to skip this step here and just go right into telling me it's 560, that's totally fine. That's your final answer.